Good afternoon and welcome. Thanks for being with us today as we introduce to you today's Innovation Bytes. I've got a very special guest today, Richard Dodsworth. That is not me. I am not Richard Dodsworth. My name is Dr. Catherine Anderson and I am the Program Director of Innovation Central Adelaide. Innovation Central Adelaide is a strategic partnership between Cisco, global technology leader, and Flinders University. We exist to assist the connection between the university and not the university, so industry, business, government, and public sector and public service. We do that through engaging with technologies, so looking for good problems to solve and ways that we can use digital technologies to solve those problems in a kind of an innovation challenge model. Our Innovation Bytes session today introduces you to somebody who I have the pleasure of working with on a weekly basis. Most days of the week, Richard Dodsworth works with me. ICA is one of 6 innovation centrals across Australia, and we're part of the National Industry Innovation Network, which itself is an initiative of Cisco. And alongside the Innovation Centrals, part of that National Industry Innovation Network initiative is to have industry alumni come and work with us. So Richard Dodsworth is one of those. He has a 30-plus year career with Cisco, and he comes to us with all of that knowledge, all of that lived experience, all of the everything that he's seen and worked with, and he brings that bounty into the projects that we work on here at Flinders University. Our session today is to listen to Richard share a look back on his career in tech in order to look forward at what there might be to come. Interactive session, so we might, given the format that we have today, that we're recording today's session, given the format, what we might do is ask Richard to take us through his presentation, and then I'll be able to come around with a mic for any questions at the end. But please join with me in giving Richard a very big, warm welcome.
Awesome. Well, welcome. It's great to have you here and to be able to share my story with you and give you some insights into what I have seen happen over the last 35 to 40 years. And then I'll speed through the beginning bit this time, and we'll get to the end, which is more about where does the future hold and what do I see happening with technology and society as we look forward. So I'll sort of stay here for the moment because we are recording it. So normally I would love to move around and be interactive, but I'll try and do my best to stay a bit stationary today. So really quickly, my career journey, so just to give you a bit of perspective of where I've come from. So I joined the technology world as an employee of the Australian government in Canberra in 1988. I did university here in Adelaide, down the road at Adelaide Uni, and then I promptly left home in South Australia and went and lived in Canberra. And really in those days there was no internet, there was no such thing as the internet, and so I was a coder, and I got into coding and looking after the mainframe that we had there. And then there's this interesting thing called networking came along about joining computers together, and I thought it was very fascinating, and so I started to think about a career in that area of technology. And so I left the government and joined a little company in Canberra that was doing this networking work and providing services to the government called Ungham & Bass. And so I started my career in technology, looking at connectivity as the main goal here. So how could connectivity help people become more effective and more efficient in the work that they did? My wife was with me in Canberra at the time. We got married when we lived in Canberra, and at the change of government from when Paul Keating left office and John Howard came to office, some of you might remember, she decided that she worked at the Prime Minister's office and decided she didn't want to work for the incoming Prime Minister. And so we decided that we would leave Australia and go and live in London and do the big Australian thing and be young and relatively footloose. So we went to the UK, and I joined Cisco in the UK in the depths of winter in 1997. And from there, I worked in the UK. I worked on some large projects in the UK and Europe, and spent a lot of time seeing the massive change, which is what I'm going to talk about today, around what became the internet and how the internet came to being. And then just to wrap things up, we left London and we were on our way home back to Australia, and we thought we'd stop in at Singapore for a year or two, and we stayed for 10. We had some children. hung out in Singapore for a bit doing some work with Cisco there, and then I brought my job back to Adelaide from Singapore and basically did the same job from here as I had done in Singapore. The Adelaide airport and I became best buddies. I got to love Singapore Airlines. I used to spend probably 3 weeks out of 4 on the road travelling through Asia and over to America. So I left Cisco last year and was very fortunate enough to find an opportunity to work with Kath and Flinders around the innovation centre that Kath spoke to you about. So that's me in a nutshell. So let's talk about what I saw in that time. So what I thought I would cover, I could talk about so much, but let's just distill it down to something I thought might be interesting, which is today we think about the internet as this magical cloud of applications and services that are available to everybody from anywhere at any time, and you don't even have to think about how do I get to these services, whether it's Netflix for your television services, whether it's social media to talk to your friends, whether it's to read emails from work, whatever it is, you and others, the world, expects them just to be on at all times. But it wasn't always like that. You know, back when I started, way back in 1988, there was no network, there was no internet, there was no ability to connect as we do today. And so what I'm going to talk about today is the impact on the plumbing, the boring background infrastructure and plumbing, and what impact that has had and the changes that we've managed to achieve in society and what it's led to because we have connectivity and what the power of connectivity has brought to the world through all of this. All right, so let's move into it. So let's roll back to the time of cassette tape recorders and cassettes, to the 1980s and the early 90s when party tapes were king, and that was the way that we shared music in those days. All right, so at about that time, people were starting to connect computers and devices together in the early 80s based off the work from the late 70s from a gentleman called John Metcalf from Xerox. And networks looked like this. They had huge yellow cables that ran down the spines of buildings, and these massive transceiver tap thingies were attached. They were vampire taps, we called them, because they had little prongs that went into the cable, and you connected your computer to this big yellow cable that ran through the core of the building, and that was your network inside the building. So that started to emerge as a way of people connecting devices inside buildings, and it's really how Cisco started. That was the premise for Cisco coming to the world and being able to offer the future that the internet became. Because at Stanford Uni, obviously in California, husband and wife team, working in different buildings, were very upset that they couldn't talk to each other and plan their evening meals and communicate with each other between the networks that operated in their separate departments and separate buildings. And so Len Bozak invented this magical box that could join the networks of the buildings together and allow the two of them to communicate between each other, between the departments on the Stanford campus. And it was such a success, and they thought it was such a great idea that they left Stanford, formed their own company in 1984, which became Cisco, which was the networking company that we kind of see through today. And of course, Cisco, being short for San Francisco, is where the name is derived because of the birth in California. And so they did their thing and then created the company. They both left very soon after. They got in some venture capitalists, and neither of them lasted very long in the private sector domain. They sold out their shares and left the business in 1990 after 6 short years at Cisco, and went off and did their own thing post the Cisco world. But this was the birth. This was the start of being able to now join buildings and organisations together with a magic box that provided that interaction. So around that same time, the way that we sort of connected all of our PCs and devices in the buildings, there was a huge fight on between all the different people around the world around what was the right choice of the local area network. And so we had these wars between all these different vendors, whether it was IBM on the bottom right there. Different people had different ideas about what was the right way to connect things up. And the message I would take from this is, you don't have to have the best solution, the best technical solution to be successful. The one that won the day was in fact the one that was the least perfect in the way that it worked, but the thing that it gave was simplicity, and it was scalable, and it was pretty much indestructible from a consumer point of view. The humble cable here, this cable, unlike the big yellow cable, which was very temperamental, these cables that we still have today are simple, cheap, very flexible, very durable. You can move them around and do all sorts of things with them, and they will still work and provide service. And so, you know, they're not technically the best option, but they won because they were easy to use and because the technology behind them was simple and very, very scalable in the way that it operated. So I guess the message here from this was all about, you know, you don't need to be the best to win. If you're going to scale, do something that everybody can easily understand and operate with. At the same time, really, really quickly here, so we had our wires and how the wires were connected and how that all operated. Every company that had their computers that they wanted to attach to these networks had their own idea of here's the language and the protocol that I will use to exchange messages between my devices on this network, and my way is the best way, and everybody should adopt my way to do things. So we had lots of companies that you know today, and some that perhaps have fallen from grace and been acquired or just gone out of business. And so there was this big war again around what was the way that we were going to join all this stuff together. And this was really led outside of a vendor, was this consortium, the IETF, a standards body, was really the first example of crowdsourcing that produced a really meaningful outcome. So the IETF ran a process where they requested for comment from experts around the world about what is the best way to create a protocol that would join devices together on this newfound network thing. And so the IETF got input from lots of smart people from these companies and others around what it would mean to create a protocol that would allow everybody to communicate easily on these cables and these wires that were running underneath all of the PCs in the network. And so the IETF won, at the end of the day, the IETF process won the war on the right way to connect devices together, and it's what we all know today as the TCP/IP protocol suite. So the way the internet works today is how it was done in the 1980s. Nothing much has changed. But the message here is that the strength, and the reason why I think this has been successful, is that nobody owns this. This is not owned by a business. This was like I said, it's a body, it's a global body that used crowdsourcing to get the smartest people to input their ideas and to create what was a foundation of specifications that everybody could apply their application to, and not focus on how you would connect things, but what you could do with the connection once it was established. And so, you know, if we think about unintended consequences here, the unintended consequence here was it has been so robust that it has not changed in almost 40 years. I mean, the way the networks fundamentally operate has not changed in 40 years. Is still there. The internet is still scaling and working the way that it does because of the work done by these people that were part of the early days of the IETF some 40-something years ago now. So I think, again, the message here is if you build a strong foundation, just like a good strong foundation in a house, you can build it to a massive scale and massive size if you get the foundation of what you're trying to do done correctly in the first place. All right, so we've established that we can build connectivity and we've got some standards that we can do stuff with. And then the mid to late 90s and the early 2000s was the dot-com boom. Now there was an explosion of people saying, hey, this is cool. We can now do something now that we can connect people together. All sorts of possibilities now arise that technology can play a role in fixing some of the problems and some of the roadblocks that we've seen in business that we can start to address because we can actually connect and share information between people. So, you know, in the 90s, some of you who had a phone like this once upon a time. Anyone in the room have a phone like this, maybe? And I managed to find some from home, these little devices, these original Nokia phones. They look so tiny these days. I used to think these were like bricks, but no, very, very tiny phones. And this was an evolution in its own right. It certainly, here, have a look. Have a phone to pass me here. They were, that in itself was a massive change, and the fact that we could start to use them to send not just phone calls, but start to text people and share text in real time and those sorts of things. So that was a massive change. But what the late 90s and early 2000s was really all about was this. The internet went mainstream. So up until then, the internet and connectivity was all about business. You had to go from home to work to be able to surf the web. Not many people had the internet at home at that point. It was too expensive. There were no services. And so the late 80s, late 90s, early 2000s, the internet came of age. And so, for those of you, and maybe you'll be able to hear this, maybe not, but, some of you may remember this sound. And the training up. This was if you go home, if you have parents, they might call this is the sound of the internet. This is the music of the internet. And every time you wanted to connect to the internet, you had to connect your little modem up and you would take over the phone line and away you'd go. And so, the availability of a simple device like that meant that people could now take what they did at work, because the work had the expensive internet connection. You can now do that from home. And as they say, the rest is history. The browser wars, the different browsers came onto the market, Netscape being one of the early players in that field. And once that was there, it was the gateway to what we know today as the internet at large. So, the impact of the plumbing behind all of this was profound. There was just a mass explosion of a requirement to provide bandwidth and services to facilitate people now wanting to interconnect with each other and use the browser, which in those days was about pretty much looking at static documents. It was like a document exchange service through a graphical front end. That's all it was. There wasn't a lot of streaming video. In fact, there was no streaming video or video sharing or all those sorts of things. All right. If you were in the technology industry, like I was, and I was living in the UK at the time, we had these really expensive things called ISDN modems, which gave us twice the bandwidth of a traditional modem. We'd have this at home. And so for me, working from home started in about 1998. So we at Cisco did work from home and hybrid working since before the year 2000. So, when the pandemic came, for us it was like, yes, we've been doing this forever. Because as a business, we invested in always-on networking services at home. But again, this was the start of the internet age. And from there, as I say, the rest is history. Now, one of the other things that was happening at this time from a technology point of view was that there was this move and this I guess, invention that came along that allowed us to take at the time, which, all our music, was on compact disc. So we had CDs and we got our music off CDs and listened to music on compact disc. We'd moved beyond the cassette tape at that point. But we still needed a dedicated player to play our music on. What some folk in France did was they invented an algorithm that could take the music off your CD and digitise it and compress it down and put it into a file that you could then load onto your computer and play the music as what was in those days an MP3 file. So a digitised version of your CD. You could cut the tracks off and create individual tracks from your CD and create these music files, which at the time was kind of interesting. No one thought too much about that, apart from the fact that it was cool and interesting, until these guys at Diamond, the Rio Diamond guys, came out and they produced the very, very first, and I have one because I bought one, MP3 player, like a precursor to the iPod. So before Apple did their thing, this was the first consumer media player that came onto the market. And the reason why I've got Fry's Electronics there is because when I used to go to Silicon Valley to visit the Cisco headquarters, the one thing I always did, as did my overseas colleagues, is we went to Fry's Electronics to see what the latest consumer electronics device that had been invented in the Valley was available for sale at Fry's Electronics. So, big shift. So suddenly, all of the music industry suddenly felt very threatened because they had lost their ability to control the sale of music through albums and CDs and that people could now get a CD, take the tracks off and then start distributing them around either on players, or as people discovered, they could do file sharing and share those music files using the internet to share those sorts of files around. And the advent of services like Napster, file sharing service, came to the fore. And so this was the birth of what we see today as being the streaming services of today. So, the Netflixes of the world, the Apple Store, the Spotifys of the world, they can all trace their history back to this humble device coming to market to show that at a consumer level, you could have a device that would be able to play out these digitised tracks that were once sitting on CDs, and they were so portable that you could move them anywhere around the world. So, massive implications, as you can see, and all brought about because you could now start sharing using this underlying internetworking infrastructure that people had. And I'll pass this one around so you'll see how lovely and light it was. It was a very cool device. I didn't use it for very long because the iPod came along, but I certainly used it for a little while. All right, so just to hold that thought about that. So I guess just to sort of, before I go on, one thing to say here, a lot of what happened around this time and the ideas that people had around producing products like this, the unintended consequences of that we are seeing today. It's been 20-something years since these things were invented. Sometimes it takes a while for invention to become mainstream, and the impact that it can have isn't seen for many, many years. And this is certainly an example where technology came to market, used the power of networking and connectivity to drive a complete change in the way society thought about music, and then obviously video was followed very soon afterwards in that sphere. All right, so we've got our internet, we've got our noisy modems, we gave up our phone lines in the evening to be able to surf the internet, but what people really, really wanted was to have the internet available all the time, like always on networking. And so technology, again, people were smart and worked out how to connect a second phone line from home and use that in a little box that could give you internet access 24/7 all the time at better speeds than dial-up. And I've got a man at the back with a question.
I think you skipped a step, the ISDN.
Well, yes, I did skip over ISDN, which was on this slide here.
Oh, okay.
Yeah, ISDN, yep. So yes, that was about the same time as dial-up. It was...
Oh, ISDN was, oh my God.
It was
64, I was getting 8K per second.
Correct, you get up to 33K up there, you got 64 or 128K here. Very good, and this was good, but it was super expensive and not a consumer product really.
But very reliable, because it was the first digital.
It was the first digital service.
It was not, audio.
Yep.
Yeah.
Correct.
Not analog signal. It was the first.
Digital service, absolutely. But from a consumer point of view, from the mass market, the change that really made a big difference there was the advent of a new technology called ADSL. So this was when in Australia, for example, the internet grew up, when it became truly, truly mainstream, became always available, and then services started to become ubiquitous, and the internet was something you could just connect to and do stuff with 24 hours a day, 7 days a week. All right? At the same time, up until now, the other thing that we sort of grew up with was you had to be physically connected. You had to have a wire from your computer to the internet. You had to be wired up and connected at all times. There was none of this roaming stuff. Even the basic mobile phone, very limited data type services. SMS was pretty much the only friend that you had for doing messaging outside of making phone calls at the time. But wireless came. So Wi-Fi, as we know it today, there's an access point up here on the ceiling. They are ubiquitous. Every building, every office, every home pretty much has a wireless device in it today to facilitate access to the internet. So interesting fact about wireless. Who invented it? Anyone know? Anyone know the history of the invention of Wi-Fi?
Cyro, radiata.
Correct. Yes, so the CSIRO were foundational in taking research that was done in Australia to create the first commercial Wi-Fi products in the world. So, if you're ever at a Trivial Pursuit night and you need a question in a hurry, throw out the who invented Wi-Fi question, and you can say that it was invented here in Australia by the CSIRO. Okay, so we as a nation can claim fame for giving the world Wi-Fi, which has become ubiquitous today. Something that's not well known is, in fact, that the technology that sits behind Wi-Fi was actually first proposed in 1940 by an actress in the US called Hedy Lamarr. And she not only was a great actress, but she was also an innovator and inventor. And as World War II was kicking off, she had these ideas that she proposed to the US Navy around how to use radio hopping frequencies to help torpedoes as they're travelling from the submarine to a ship, to change the frequencies of the radios that the torpedoes were using to home in on the ship, so that the radio frequency couldn't be intercepted by the enemy and the torpedo diverted away. And so her frequency hopping radio idea that she patented back in 1940 is the basis of what CSIRO used in the late 90s to invent commercial Wi-Fi. And so it's a very interesting story that something that happened, an idea from 50 years ago in the 1940s, came to life in the 1990s to give us what we have today around Wi-Fi. Again, nothing to do with what she envisaged, but it's amazing how technology can be reused and rethought of to use in a completely different way to provide the service. Okay, so an amazing change in that sense. All right, and around that time, and this is something that I spent a lot of my life working on, and I think this was a really foundational shift in what was possible with the internet. And we'll spend a couple of minutes on this topic. So up until this point, which is about 1998, 1999, there or thereabouts, the internet was primarily about shifting data, like files or emails or those sorts of things. There was no concept of shifting streaming video or telephone calls or any of those sorts of things over the internet. Any of that real-time information, real-time flow of traffic was something we didn't do. And it was something that Cisco came up with and thought, wouldn't it be cool if instead of having a video network for your video surveillance stuff in the office, a voice network for your telephone system in the office, and a data network for your data services, wouldn't it be great if we could put them on one single piece of wire to your desk and have a single network that catered for all of these different types of services that people were using in their daily life? And so this was something that I worked on and created when I was at Cisco. And so the idea here was that we would collapse all of the data that was existing within the world onto one single wire and one single network, basically running over TCP/IP over Ethernet for everyone to use. And so we came out with these very, very fancy phones. These are phones that I have at home in a box, much to my wife's chagrin. So, looked like phones, but they connected to the network. We had all sorts of other devices that we connected to the network to act as gateways between the phone systems. But this, again, was the start of what became, we took the compression algorithms from the MP3 space. We combined it with some of the compression techniques that we used to get this stuff over a network. And this is the foundation of all of the services that the streaming video providers provide today. It's what everybody uses when they do their voice calls and those sorts of things from social media, all those sorts of things are based off the work that we did to ensure that the quality of the voice and video over the network was maintained through these interactions. So it had a massive shift, not just at the time in saving money on the cabling and a single network, but what we see today in terms of the consumer services that are now possible because we did the work back then to interleave and integrate all the different types of traffic that was coming across the network to make sure it worked. So quickly through a couple of things, and then I want to get onto AI and looking at the future. So mobility, we've talked enough about this. This was not a surprise. Phones went from those little beasts to these multi-button devices that we saw over time. These were the 4 phones that I had. I had these at various times in my career. But essentially these were just becoming smarter and smarter and smarter and offering more and more applications and services off the mobile device. You didn't need a computer or a laptop to do your work anymore. You could start to use mobile devices, and that again obviously had a massive, massive change to the world. The other big change here was something that we see in action today, but the cloud, as we know it, so we all talk about, it's in the cloud. You get it from the cloud. So where did this cloud thing come from? So the whole premise for the invention of the cloud came from this idea that instead of having racks and racks and racks and racks of servers, as you see up there on the right-hand side, each one of them running its own application and its own service, wouldn't it be cool if we could utilise all of the disk space and all of the CPU and all of the memory by putting multiple applications on one physical server? And so when one application was busy and the other one wasn't so busy, we could maximise the usage of all of the resources that sit on that physical box. Whereas at the time, it was a one-for-one, and if it was not so busy, then the box wasn't doing much, and another box might be super busy doing its thing. So we saved a whole bunch of hardware by putting multiple services on one physical box, saving money, more efficient, much, much better. We could network all of these devices together, and so that was magnificent for the business that was running these things. And then someone had this cool idea and said, you know what? We don't need to do it in your data centre inside your building. We could put this stuff anywhere because it's on a network. And so that then gave birth to data centres that were specialised in storing computers with applications running on them, and it's what was the basis of AWS, Microsoft's cloud, Google's cloud, Oracle's cloud. All of those providers basically took advantage of this technology to build out their massive data centres that you see today and offer the cloud services, as they're called, to the business. So the business doesn't have to care about managing, maintaining any of that stuff on the right. That's all given to the provider of the cloud service, and all you do is buy your application at a user per month charge, and you get your service as you need. And so the idea of saving money and making the servers that I had more efficient eventually led down the road of the formation of the cloud and the software as a service type applications that we saw today. And again, I spent a lot of time, again, working at the best utilisation models of these devices and how to make them operate at peak efficiency and peak interconnectedness. But moving to the cloud had a disadvantage in some ways. Up until now, security was easy on a network because everything was within your domain. All right, and so you could have almost like a moat, and so you had a big wall or a big moat around your business, and you just had a drawbridge that you let stuff through that you wanted to because everything was otherwise enclosed from a data perspective. Really quickly, as applications became more distributed, the internet became more distributed, there were more access points for people to try and circumvent your organisation to steal information or create havoc, and so this obviously gave rise to what we see today around the importance of cybersecurity. In the old days, it was just about viruses, virus protection. These days, it's about ransomware and all of that, and I'm sure all of you are well familiar with that. It's got to the point now where even the most senior members of an organisation on the board, they care about cybersecurity because of the impact to a business if you are breached through a cyber incident, whether it's to reputation, information loss, or any of those sorts of things. So, sometimes the unintended consequence, again, of being open and having things distributed is the payoff is your increase in security. So, an entire industry managed to create itself based off, the access that we saw being created through this virtualization world. Which leads us to almost to today. And let's spend a bit of time on this particular topic here. So today we have the ability to capture data and warehouse data. We can collect it from all sorts of places. We can use the network to bring in data from all sorts of different sources and warehouse that data. And then companies like NVIDIA, who started their life off over here on the right-hand side as a company that built graphics cards for PCs, basically their world was all about providing high-quality graphics interfaces for screens and those sorts of things. But they also discovered that the graphical processing unit that they used on those cards was super, super good in the world of machine learning and artificial intelligence. And so they kind of steered their business a little bit to the left, if you like. And these days they are acknowledged as the world leader in the chipset that is used to do all the machine learning and all the inferencing and all the AI work in pretty much every workload around the world. And so, something that started off as a graphics card has become the premier artificial intelligence machine learning GPU that we use today. So again, not something they thought of when they first started up, but by golly, they've made a lot of money out of it in the last 5 years by being that person. And so being able to collect a lot of data, having the ability to have the computing power and the algorithms to parse that data to create the machine learning environment and learn what's going on, and then to be able to create the replies and the responses back has got us to where we are today around the pretty universal ability. It's very nascent, it's probably in the first 10 minutes of its life, the beginnings of something to do with the use of artificial intelligence. And so artificial intelligence, really quickly, I look at it as two bits. One is the interactive piece that we see today with tools like ChatGPT or Copilot or Claude or that kind of stuff, where we type in queries and we get back answers and can have conversations with something behind the scenes there to get information. On the other side is a set of features and functions that is all about automation. So how do we use machine learning to learn and recognise and do repeatable type of operations is the second part of the AI journey. And I think, from a public point of view, it's all about the interactive bit today, but the true power is combining that with the automation and machine learning piece that I think is in fact game-changing in what we can do from an automation point of view, and making decisions based on observation. So see something happen, take an action automatically. That's the power of AI that I see going forward. The implications here, and maybe in the Q&A we'll get into some of the implications around this, but again, we are at the beginning of this journey. There is so much that we don't know what we don't know. We don't know a lot of the consequences. We don't yet know of the unintended consequences of some of this work. So to finish off, this is kind of where we are with the future and the near future and things to look out for. Top left, quantum computing, whole new paradigm in how computers operate and how they solve problems and process information within them. Basically bigger, faster, better. That's a really bad way of describing it, but basically that's what you get from it. We've got this hyper connectivity world now where everything is connected, and that's brilliant and dangerous all at the same time. And it really takes us back to that beginning slide that I had, where that's the expectation is today. You can be sitting here, you're bored with what I'm saying, you can get on your phone and look up anything you like on your device because everything is hyper connected. And the other thing that I see more people interested in understanding is the impact of technology on the climate and on usage of resources like energy. So there is a ton of work going on at the moment around how to optimise the use of energy with all of this technology that's consuming energy and water and all those sorts of things to make it work today. And so that's the other area that I see a lot of work being done by researchers and by vendors, is around optimisation of energy usage for the outputs that they are creating. So I expect to see a lot of work done here, and maybe there'll be some regulatory environments here, rules from the regulators that come in here around meeting minimum standards before you can deploy your devices, your technology into the world if you don't meet certain energy usage benchmarks going forward. Because today it's open slather, you can do what you like, and it hasn't been a care. All right, so just to reflect back really quickly, it's been a very interesting 30 plus years in the tech world. A lot of what I've seen has been, I've been involved with a small portion of it, but when I look back, it actually has had some pretty interesting impacts on where we are today and the capabilities that we have as a society, and it's been super cool to have been involved with that. I think, and I mentioned it earlier, I think one of the biggest reasons why the internet works is because it belongs to nobody. It was formed out of an idea of a crowdsourcing approach where the biggest and best minds came together to throw their ideas in to create the right specifications for what we have today. And it's why we haven't changed it, really. I mean, it's morphed and it's moved a little bit, but it hasn't fundamentally changed in all that time. And, you know, it was a winner because it was simple, because people agreed with it, people could easily interoperate with it, and it gave us what we needed to create all of the interesting and exciting applications that we see today. And with that, I will hand back to Kath for questions. Thank you so much.
Stay there. We are recording, so that's why I've got the handheld mic. So nice to see a few more have joined us during Richard's talk. We do this twice today, so this is the second time. It's, again, still really amazing to listen to it and to reflect on those moments way back when, you know, including the only one phone at a time kind of years that we spent with the internet at home. I'd like to open the floor for some questions. Where do you start? Do you start with questions about what used to be? Do you start with questions about what's to come? I'll run around and bring the mic to you as well so we can capture your question on mic.
The question is that... Thank you very much, actually, for what you... you bring up memories of the past. And I can... what's coming in my mind that all this knowledge that is in your head and all of these technologies that it was in the past years, and with all this latest technology of generative AI and now how the new generation is feeling the technology, that is just you communicate, you touch screen and all of that, and all of this is get decoupled from the foundational models and all this. Actually, the foundational stems, you know, all this physics, mathematics, all of that they've been based on that.
Yep.
So, I would like to know what is going to be, you know, is there any strategy of something that we have to bring back these things, you know, hand by hand, especially with the new generation, to start teaching more fundamental things like this, for example, you know, how it was the floppy disk or how it was the hard disk and these electromagnetic fundamental things and
I
before we go to quantum.
Yeah, exactly. Look, it's an opinion, I guess. I'll give you an opinion. It's not an answer, but it's an opinion. I think fundamentally that success comes from understanding the basics. Like if you can understand the basics, the foundation, I would call it foundation basics, whatever it is that exists, then you have a great place to start from to then move to the next thing. I think it's really, really tough, and I've observed it with people that came to work for me and different bits and pieces of the business that I ran for many years. Those that got interested in the why and the how it happened at the under the covers, like what happened under the covers, were far more successful than those that came in and just stayed at that high level and then tried to go somewhere new because they had no foundation on why it was that the thing that they did was successful. They just thought it was magic and they could take the magic somewhere else without understanding what was happening under the covers. So listening to your question, I'm kind of going there. I think this is where your question was going, and you can tell me if I'm wrong. But I think going back to the basics sometimes is a good thing before you go forwards. Because if you understand the basics, back to basic maths, basic physics, basic whatever, the journey is important as well as the destination, because you can't go to a new destination if you don't understand the journey, I don't think, of where you've come from. And that, I think, is foundational to success. I know, like I said, it's a comment and an opinion. I don't have any facts to back that up, but I kind of agree with what you're saying. Yeah. So yes, understanding what's going on under the covers, I think, is super important to being able to go forward. Yeah.
Other questions?
Yeah. Oh, go for it. Welcome.
First of all, thank you so much for presenting this whole history of technologies and how not just the technologies evolve, but as a human interacting with the technology, how we got evolved as well. So as you said, like, you know, at first, we noticed that whenever we want to go onto internet, we become very isolated because, like, you know, we can't use the phone anymore. And because that was my time as well. Like, mom is like, hey, what's going on? Like, I have to go onto the internet. And then, like, now I can't use the phone. But now everything is well connected. So my question is, for the next step right now, moving forward, is it people are still eager for getting much more connected, much more quicker, or we're actually looking for being isolated? The reason why I asked this question is because me and my wonderful woman partner, we are actually developing a VR experience right now. So this is a very important question for us, is that are people wanting to dive into a more isolated experience that they could interact with the rest of the world, or they're still looking forward to be much more connected in a much more quicker way?
Yeah, I think it's a really interesting question because, you know, something, I'll go on a tangent for a moment and I'll come back. You know, we are more connected than we ever were, but there's much more loneliness in the world than there ever was. So it's a bit of a conundrum, to be honest. You know, I think in many ways people are able to find people who are similar to them much more easily and create a little bubble that they live in because they found people of, you know, like-minded people stick together. They're not having to defend against people who disagree with them as much as in the past, where in the past you couldn't find all your friends that agreed with you. You had to sort of be robust and argue your point amongst the majority of people. And I think some of that's been lost because people are more connected than they were. And it's created in some ways, I think, a little bit of isolation because it's much more comfortable to not have to argue with everybody all the time, but to have, you know, people that you agree with all the time, and you can sort of, you know, like the echo chamber is real. And so I think that's something we have to be a little bit careful of, you know. And I think that's coming to roost now in society, is we're seeing the impact of that a little bit today. You know, if you hark back to like 30 years ago, before the internet, you know, if you wanted to, you kind of didn't have that ability to find people as easily, and you had to spend more time, you know, in public debate and being more, you know, not combative, but more up there for a debate in a critical way, and accept that you weren't always right. You didn't, you know, you could say, oh, okay, I can see your point. Okay, I can adjust and move on and change. Whereas today, you can easily sit in an echo chamber and never change your mind because all you've got are people saying, yes, you're right, I agree. And so I think as a society, we lose a little bit if we don't accept that we need to get out of our little echo chambers and debate things to move stuff forward. Now, to your question. I think people want both. I think people really enjoy, like, we are so connected that people actually crave a bit of me time. And so there is time when people want to go, you know, this is about me. Cathaways talks about, I'm going into the cave. I'm going to go do some work in the cave. And, you know, for me, that's like, I need some alone time to go focus, do things on my own because that's what I need to do. I need my time with others to collaborate and work with them as well. But I do need my alone time and disconnect time. And perhaps, you know, as you're working on your project, maybe that's a way of thinking it. It's not a question of one or the other. It's about when is the right time to be involved in both spheres. Anyway, again, an opinion.
That's a great question to kind of wrap on, I think, actually. Not in a hippie hop kind of way, but just as a wrapping up the session kind of a way. Thanks very much for being with us in person today. If you are watching, I think that's our camera there, if you are watching us online, we are recording this so that we can have a look later and reflect and be able to review the session. One of the interesting things that I can reflect on out of that last question is that Innovation Central Adelaide and each of the nodes of the National Industry Innovation Network sit in a university physically, as a physical space, as a physical presence. And part of that is that difference between, you know, we talked recently about there was this idea that technology was going to come and remove all the barriers and you could really literally do anything from anywhere, which you pretty much can. But we still want to come together as people face to face in physical proximity to each other and with each other. So thank you for being physically proximate with us today. It's been an absolute delight to have you with us. There's still some food and drink if you'd like to keep chatting with us. We'll be around for a few more minutes. I hope to see you at our next session, but please join me one more time in saying thank you to Richard Dodsworth.
Thank you. It's been a pleasure.